Modern CPUs are optimized for performance at the cost of power consumption and thermals. Today I wanted to take a look at tweaking a CPU so that it has lower power consumption and better thermals, and seeing what type of tweaking works the best under different workloads. So I've ran a good amount of different tests of different types of workloads on a system with different types of tuning, including underclocking, setting eco mode to lower the TDP, setting a static low clock on the CPU, and a combination of those. My test system had a Ryzen 9 5950X as the CPU on an ASRock X570 Ti. This motherboard is kind of tuned towards gaming and enthusiasts, so it has all the little dials and controls to adjust a lot of the power settings. Unfortunately, a lot of other systems, especially OEM systems, don't have all these knobs, so you won't be able to do all the tuning I did today, but it does give a good insight about what type of tuning affects what. The different test conditions I used on my CPU were stock, so just the stock settings by ASRock and AMD, and I always use this as a starting point for the other tests. The next one I used was no SMT. So instead of having 32 logical cores, the system only had 16, so it only had one thread per core. The next thing I did was eco mode. So eco mode on this CPU limits it to roughly a 65 watt TDP instead of the 105 watt stock. I'm guessing this is relatively equivalent to buying a low TDP CPU from the factory. It's just that's enabled from the factory instead of being a toggle that you can turn on in some motherboards with eco mode. I tried undervolting the CPU, so I took all the stock settings and used an adaptive voltage change so it would just go down 150 millivolts from whatever it requested. I think these modern CPUs are doing something a little bit smart because my single-threaded CPU performance had a noticeable drop, and I'm guessing it just knew it didn't have enough voltage, so it lowered the max boost speeds by a little bit. I then tried combining eco mode and that undervolt, so it had 150 millivolt undervolt and the 65 watt TDP limitation of eco mode at the same time. And then the next thing I tried was just an underclocked CPU. So I ran the CPU at a static 3 GHz, 0.9 volts, and it would never change. So there's no boosting, and it wouldn't drop CPU frequencies during light loads either. I kind of ran two series of tests. One was using hardware info to log the data consumption from the CPU reported as I ran different tasks. But instead of just measuring the power consumption during the task, I measured the power consumption over 10 minutes, and the task had to complete within those 10 minutes. So for example, I had 10 minutes for Resolve to render out a video, and then it would idle for the rest of the period. So if the system could go faster, it would spend more time idling when it's over, but if it was at a slower setting, it would spend more time rendering the video and less time idle. As I see, that's a relatively real-world use case because you don't just shut down your system the minute the task is done. Your system goes to a lower power mode or likely something in the idle state. I also used wall power from the system just to take a look at how it actually came from the wall and to make sure there wasn't any issues with the onboard power monitoring on the system. And I primarily used Cinebench to see a good example of exactly how the performance changes in these different modes. So let's first take a look at idle power consumption. So idle power consumption was roughly about the same on all of the system's configurations. And I'm guessing that's because it was just running in the C states, which kind of just turns the CPU off. So no matter what frequency it's kind of set to, it doesn't run at that frequency, it's just off almost all the time. But idle has to be really idle for this to happen. Even if you're running things like hardware info in the background, or task manager, or a browser doing something, pretty much any of the background tasks that I see are very common for my use case and many others would knock it out of that idle mode into a much higher power state. And then there seems to be a substantial difference between the different modes of the CPU. It's a relatively small difference at these lower power consumptions, because likely more of the power is being used by the I/O controller and other parts of the CPU, not the actual cores, but I saw a bit over a 5 watt delta between the lowest power consumption of my 3 GHz 0.9 volt underclock and the highest power consumption of stock. For load testing, the average result was that the underclock and the undervolt was running at the lowest power consumption, and then eco mode and undervolting the CPU, and then eco mode and the undervolt on their own performed roughly the same when it comes to power consumption on the CPU, and then stock with no SMT being actually worse than stock. Now I'm going to take a look at my Cinebench results to see how the different power tuning affects the single-threaded and multi-threaded performance of the CPU. So first, taking a look at single-threaded performance, the eco mode didn't seem to affect it at all compared to stock, with about the same. Undervolting the CPU seems to have a little bit of an effect, likely because it has a lower voltage so it knows it can't hit the highest possible clock speeds on that chip, And then way down at the bottom is that 3 GHz clock speed. Because the CPU can clock all the way up to 5 GHz in its maximum boost, 3 GHz is quite a drop when it comes to single-threaded performance. But it also did have quite the drop in power consumption, using about 25 watts less than any other configuration from the wall. Now let's take a look at multi-threaded results. And the next thing that I notice is my 3 GHz 0.9 volt configuration seems to really be saving a lot of power with still actually pretty good performance. So it was a 20% performance hit, but 100 watts less at the wall, going from roughly 250 watts at the wall to 150 watts at the wall. A huge efficiency improvement compared to the stock settings on the CPU. The other thing is it looks like the undervolt is pretty much always a net gain. It didn't seem to affect performance almost at all when it was running with multi-threaded performance, but it saved power. So it's kind of a why not configure it that way. Looking at my real-world test scenarios with a 10-minute timed period with idle after the program finished, it gave me roughly the same results. Undervolting seemed to only give benefits when it comes to efficiency with basically no performance differences compared to running at the stock voltage, and the 3 GHz 0.9 volt static clock that I ran was much better than anything else when it came to efficiency. The takeaways I had here was undervolting is a pretty big improvement for the CPUs. You get more efficiency, and if it's TDP limited or thermal limited, you get a reasonable amount more performance compared to running it at stock. The problem is it could cause stability issues, and there's likely a reason why the manufacturer set that voltage at the one they did. Maybe a few CPUs need a higher voltage to run stable in all situations, or maybe they wanted to take account for like maybe a little bit of air and the motherboards all being different and just kind of relatively wanting to play it on the safe side because being a bit less efficient in the CPU is a lot better than being a CPU that crashes at times. Eco mode and other TDP limiting seems to help the most when you're under a heavy load where it's using a lot of power, as it'll force the CPU to run at a bit lower clock speeds that will be more efficient. But when you're under light loads where the CPU is boosting, it seems to act roughly the same way as the high TDP version because they're just both running under their TDP limits. Sometimes the low TDP versions that come from the factory are clocked a bit lower that'll likely help because it's more efficient at the lower clock speed, but they're roughly the same unless you're pushing the chips to their max. But for a lot of situations, I can think it makes sense leaving it on, especially like servers. Saving 20 or 30 watts on average all the time for like a 10 to 20% performance cut makes a lot of sense. The 3 GHz 0.9 volt static clock speed was a lot better than I would have expected, and actually makes a good amount of sense for me in a lot of server systems. Because if you have a server that's running with kind of a moderate load all the time, that underclock and undervolt will actually save quite a bit of power without a huge performance hit. Saving that amount of power every year can actually be a pretty considerable cost savings in some areas with that more expensive electricity. But unfortunately, a lot of server systems don't let you tweak it in this way. You can't set a static voltage and a static clock speed on the CPU. I'm going to leave my desktop running at the undervolted and eco mode for a little bit because I like it and because my fans can run silently under all the different loads that I have, and I don't even see that big of a performance hit. And saving a little bit of power is nice. Let me know if you've done any tweaking to try to save power consumption on your CPUs and how that has worked for you.